This is going to be Chapter 9, Practice Test A, Solutions. The sample size is n equals 500. The population proportion in the problem is 0.45. We have to start with the assumptions. Is the actual population greater than 10 times the sample size? So I'm going to insert 500 for n, and it's safe to assume that there are more than 5,000 adults in the population. Our next question is, can we use normal approximation for this problem? If n times p is greater or equal to 10 and n times 1 minus p is greater or equal to 10, then we are allowed to. So I'm going to insert the numbers and see what we have. So 225 greater or equal to 10. This one checks out. And 275 greater than or equal to 10. This one also checks out. So we are allowed to use normal approximation. The question posed to us in the problem is the probability that more than half of the sample is in favor. In other words, is the probability that p hat is greater than 0.5. We need to find the mean of p hat, which is equal to p, which is 0.45, and the standard deviation of p hat, which is the square root p times 1 minus p over n. Plug these numbers in and see what we calculate out. .0222. We can use these to calculate our answer. To calculate this, you can plug those numbers into the normal CDF. So you're going to go 0.5 to infinity with a mean of 0.45 and a standard deviation of 0.0222. You would calculate out 0.0122 rounded to the nearest 10,000th. You could draw a sketch of this, and I've already labeled my mean and then plus 3 standard deviations and minus 3 standard deviations in each direction. Estimating about where 0.50 would come would be just past the second standard deviation. So I'm going to shade above that point. So we have a sketch to go along with our answer. The last step is to interpret our answer. There is a 1.22% chance that more than half of the adults sampled are in favor of vouchers. Part B of the problem is asking us to calculate the probability of the proportion of people in favor would be within 5% of the population proportion. So that's in between 40 and 50%. Doing a normal CDF calculation with a lower bound of 0.4, upper bound of 0.5, mean of 0.45, and standard deviation 0.0222 gives us 0.9757. Interpreting this, there is a 97.57% chance that the proportion of people in favor in our sample would be within 5% of the population proportion. In the sketch, the shading would go just to the left of 2 standard deviations and just to the right of 2 standard deviations. Going back to our text, Rule of Thumb 1 states that as long as the population is at least 10 times larger than the sample size, we are allowed to use our calculation of the standard deviations for the sample. In number 3, that deals with Rule of Thumb number 2. We are allowed to use normal approximation if n times p is greater than or equal to 10 and n times 1 minus p is also greater than or equal to 10. A key point to notice in number 4 is that in the problem it stated that it was approximately normally distributed. In answering the question, what is the probability that a randomly chosen freshman stays more than twice the average number of hours, you have to double mu from the given problem, 7.2, to get 14.4. And you do a normal CDF calculation with a lower bound of 14.4, upper bound of 1E99 or infinity, with a mean of 7.2 and a standard deviation of 5.3. And you would get a calculation of just above 8%, so about 8.72%. Sketching it on a normal curve, that you would start the sketching where about 14.4 would fall, which is just between 1 and 2 standard deviations to the right of the normal curve. In part B and C, we are dealing with a sample of the population. So the mean will stay the same at 7.2, but we have to adjust the standard deviation for our sample. The standard deviation for the sample is the standard deviation of the population divided by the square root of n. Here we have a sample size 55. So 5.3 divided by the square root of 55 is 0.715. Our sample distribution would be approximately normal with a mean of 7.2 and a standard deviation of 0.715. Using this to answer our question in part C, what is the probability that the hours studying are greater than 14.2? The probability of x bar being greater than 14.2. I input into normal CDF a lower bound of 14.2, upper bound of infinity, mean is 7.2, and our sample standard deviation is 0.715, and it comes out to be 6.3 times 10 to the negative 23rd, which is essentially 0. In this problem, they're asking us about the sampling variability of two different samples. These two samples are both the same size, 1,000 Americans and 1,000 Canadians. Therefore, their sampling variability would be the same because it is a fraction of the sample size, which is also the same. The standard deviation of a sample is equal to the population standard deviation divided by the square root of n. Doubling the sample size would be multiplying n by 2 in this fraction. By taking out our factor here, we can find out what we multiply to our standard deviation when the sample size is doubled. So this is also equal to sigma over the square root of 2 times the square root of n. So what we're actually multiplying to our sample standard deviation is a factor of 1 over the square root of 2. So a little more algebra. In this problem, we use some of the information from problem number 1 with a population proportion of 45%. They want us to figure out how large a sample would need to be to guarantee that the standard deviation of p hat is no more than 0.01. So, plugging in 0.01 for our standard deviation and plugging in 0.45 for p hat, we can solve for n. To get rid of this square root sign, I squared both sides. Then, multiplying both sides by n and dividing both sides by 0.0001, we can get n by itself on one side of the inequality. N comes out to have to be greater than or equal to 2,475. In this problem, we're using a previous problem from the practice test, where we had a mean of 7.2 hours, and we take the population standard deviation divided by the square root of our sample size, and we have our sample standard deviation of 0.715. Now, since n was greater than 30, our 55 size sample is greater than 30, we're allowed to use this normal approximation. Now, there's two ways we can go about trying to solve this problem. One using a calculator and one using the z-tables from our packet. I'll go over both. They want to know what the number of hours n is such that there is a probability of 0.10 that the mean study time of all 55 freshmen falls below n. A sketch would put n a little bit more than one standard deviation outside to get 10% below. If you use your calculator and you use the inverse norm calculation, you can put in the 10% with a mean of 0 and a standard deviation of 1 to give us a z-score. Another way to get that z-score would be to use our table. Looking at this table, we want to find negative 1.28 on here. That's our goal. What we do know is that the area below is 10%. So I want to find the proportion, the area in here that's closest to 10%. This one, 10.03% or 0.1003 is the closest thing we have to 10%. And that z-score is negative 1.28. So either using the calculator or using the table, we can come up with this z-score to plug into z equals x minus mu over sigma. Now we know mu and we know sigma. What we're looking for is x, this value that has an area of 10% below. So doing a little algebra, multiply both sides by 0.715 and then add 7.2 to each side, we get 6.28. Therefore, the value n for this problem has to be 6.28. Okay, this page contains probabilities. The first problem says find the probability that 20 of the 50 polled do not like winter. They told us that 34% of all Michiganders do not like winter. So the probability that x is exactly 20 would be 50 choose 20 times 0.34 to the 20th times 0.66 to the 30th power. So 50 choose 20 can be done on your calculator. The 0.34 to the 20th power is because the 34% do not like winter, so these are the 20 that don't like winter. This is 0.66 because 1 minus 0.34 is 0.66, which means that 66% like winter. So 30 of the 50 that like winter is the exponent on the 0.66. Or your calculator has a function called binom PDF where you can put in the number, the probability, and the number that you want associated with that probability. It would give you the same answer. The next problem says find the probability that more than 20 but less than 30 of the 50 polled do not like winter. So I wrote that out as a single probability. The probability that 20 is less than x, which is less than 30. That's equal to the probability of x less than 29 minus the probability of x less than 20. 30 became 29 because we don't want 30 involved, just less than that, so that would be 29 and below. But we want it to be more than 20, so 20 isn't in our numbers, so we can subtract 20 and below off from that. Putting this in our calculator, this piece is binom CDF, cumulative for more than one trial, of 50.3429 minus the binom CDF of 50.3420, giving us 0.1481. Now, if someone were conducting the poll, what is the probability that they would have to contact 5 Michiganders before someone answered that they disliked winter? This is a geometric problem. So the probability of how many problems before a success. So the probability of x equaling 5, that would be the first 4 people would have liked winter until we finally got to 1 that disliked. So it would be 0.66 to the 4th times 0.34. Or you could have done a PDF calculation on the calculator, entering in entering in your probability and the number of the trials that you wanted it to be a success. So 0.34 didn't like it. So this would be the probability of it being the 5th one that finally disliked winter. What is the probability that the first Michigander that answers that they dislike winter is the 8th person polled? Very similar to the previous problem. We're just going to calculate until x is equal to 8. That means the first 7 people actually like winter until you finally get to the 8th person that dislikes it. Similarly as before, you could enter this into your calculator using Ch9 PDF of the percentage, 0.34, and then this being the first trial that this happened. Now, figuring out the mean and the standard deviation of x for number 14. It said, assume that 50 Michiganders are polled. Let x equal the number of people that answered that they dislike winter. So the mean of x is equal to n times p. That's our formula that we need to show. N is 50 and p is 0.34. So n times p is 17. So the mean of x would be 17 Michiganders. The standard deviation of x is equal to the square root of n times p times 1 minus p. Plugging in our numbers, we come out with 3.3496 Michiganders.